Today, we are diving into the chi-square test and the power of categorical variables. If statistics ever felt like a wall of numbers, don't worry. This concept is actually quite intuitive once you see the business application. Categorical variables are data points that are divided into groups or labels, not numerical values. These are the backbone of many business surveys. For example, employee satisfaction is measured by the options satisfied, neutral, or dissatisfied. The department variable includes finance, marketing, or operations. Product preference is categorized as product A or product B or product C. The key here isn't a number. It's which group or bucket the data point falls into. We see this all the time in customer feedback, HR satisfaction surveys, and campaign responses. The chi-square test is a tool you use to answer a critical question. Is there a meaningful relationship between two categorical variables? For example, you might ask, is there a difference in the satisfaction level across different departments? Is the preference for product X the same for men and women? It's the test that determines if your two categorical variables are related, dependent, or unrelated, independent. Just like our previous video, every statistical test starts with hypothesis. Here, the null hypothesis assumes that there is no association. The two variables are independent, whereas the alternative hypothesis assumes that an association exists, so the two variables are dependent. So the null hypothesis means the department a person belongs to makes no difference to their satisfaction level. In other words, the department and the satisfaction level are not related. The alternative hypothesis assumes that the department and the satisfaction level are related, meaning satisfaction may vary by department. The next step is organizing your raw data into a cross-tabulation table or contingency table. And this table shows your observed counts. The actual number is you collected. By looking at the crosstab, you can intuitively see where the difference lies. For example, Department C has a 50-50 split, while A and B lean toward satisfied. The core of the test is comparing your actual numbers observed against the numbers you would expect to see if the null hypothesis, no relationship, were true. Expected count. This is what should this box contain if the variables were completely random, unrelated. For example, in the Department A satisfied cell, expected counts equals total satisfied multiplied by total department A divided by grand total, approximately 11.4. The chi-square value is simply a sum of all these differences across every cell. The chi-square value, written as chi-square, simply measures how far what you observed is from what you expected. For each category, you compare the observed and expected counts, find their difference, square it, and then divide by the expected value. Finally, you add them all up, and that total is your chi-square value. So bigger differences, you will see a larger chi-square values, and then it becomes stronger evidence that the variables are related. The calculated chi-square value is then used to find the p-value, the final verdict. If p-value is smaller than 0.05, we reject the null hypothesis and conclude there is an association. So the department do have different satisfaction level. However, when p-value is greater than 0.05, we fail to reject the null hypothesis, so no statistically significant association found. So for example, if your test gives a p-value equals 0.12, which is greater than 0.05, you fail to reject the null hypothesis. So there is no statistically significant relationship between department and satisfaction. Any differences you see in the crosstab are likely due to random chance, not to department itself. You can immediately apply the chi-square test to critical business questions. For HR surveys, is there a relationship between department and intent to live? Or when it comes to customer feedback, is there association between the customer's origin and their complaint type? Or when it comes to marketing, is the effectiveness of a campaign creative related to the platform it ran on, like Facebook versus Instagram? This test gives you the objective evidence to decide where to focus your resources. So remember the 5 key connection points we built today. 1. Categorical data. Groups and labels are the focus. 2. Hypothesis. There are the null hypothesis and the alternative hypothesis. When it comes to the chi-square test, you can create a course tabulation table or contingency table to organize and see your observed counts. 4. Expected versus chi-square values. Compare what you saw to what you expected if there's no relationship. Finally, use the 0.05 rule to make your final evidence-based decision. Statistics isn't about the chi-square formula. It's about interpreting the p-value to strengthen your argument and lead with confidence.